Hi everybody, welcome to Math 1332 review. Question number 1. Determine the most probable next term in the sequence. So we look at this sequence. If we see the parent and we follow that, we can find out what the next number will be. So 34, 28, 22, 16 and 10 look like the difference between them are 6. So subtract 6 every time, and with that we got the next number. So subtract 6. So next one will be 10 minus 6 will be 4. Right, so just like that. Oh, I'm writing timestamp, so at in the description you just click on the time for a particular problem. Right, next we have a deductive method to solve the problem. So we just follow this So if we start with the number, double its values. If it's x, double will be 2x. If we add 10 to it, be 2x plus 10. And then divide by 2. So I will do that over here. 2x plus 10 divide by 2. So here I can split the fraction. 2x over 2 plus 10x, 10 over 2. So that is x plus 5. So we're just going to write x plus 5 here. And then subtract the original number. Well, we have x plus 5. Subtract the original number, which is x. So x and x cancel out, we have just 5. So if we do this, the answer is going to be 5. Doesn't matter what x is. So deductive reasoning, doesn't matter what we start with. The answer after this sequence of operation, always 5. Right. Right, next. We have these two problems here. Usually that's a way to do that using algebra, but now we just do the reasoning and use that to do this problem. A mouse is at the bottom of the 10-foot tall clock. Every hour he climbs up 3 feet, but when the clock strikes at the hour, he falls back 1 foot. If the mouse starts climbing at 8 a.m., at what time to the nearest minute will reach the top of the clock? Right, so in that case, I said there might be formula using algebra, but I'm just going to do the simple reasoning here without any high level of math at all. So the 10-foot tall clock, 1, 2, 1, okay, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So this is the top of the clock. Like that. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay. Now we start at the bottom at 8 a.m. So when a mouse, when it climbed 3 feet an hour, when the clock hit, he fall back 1 foot. So I'm just going to say it. If we go here, and then when it hit 9 o'clock, it go back. So this is where it's 9 a.m. Then you climb 3 feet, and then the clock strike, it drop back, so 10 a.m. it will be at this point. At this point. And then go 3 up and 1 down. That's 11 a.m. Then go 3 up and 1 down. So that is noon. And then there'll be 2 more notches. And we hit the top of the clock. Now, if so, this is 12 p.m. plus 2 notches. I mean 2 feet. And we said every hour 3 feet. So 60 minutes. Can climb 3 feet. And we only need 2 feet here. The mouse only need 2 feet there. So 60 minutes for 3 feet, meaning the speed is 20 a minute for 8 feet, for 8 foot. So there are 2 of them. So we have 40 minutes. So it takes 40 minutes for the mouse to climb 2 feet. So we have 40 minutes after 12. So that is will be 12:40 p.m. Right. Next. The number of dogs and chickens on a farm add up to 12. The number of legs between them is 28. How many dogs and how many chickens are on the farm if there are at least twice as many chickens as dogs? Right, so all we know is at least twice as many chickens as dogs. So we don't even need that information. So let's think about this. Of course, there is an algebra method for this. We're not using that. We just use strictly reasoning here. So a dog has 4 legs. A chicken has 2. So, and there are 12 total, right? So we just start with this. The number of dogs and chickens are 12. So we have 12 total. And the total feet 28. Now think about this. We can work it either way. So let's say this is the number of chicken and number of dogs. Now, if we have all chickens, of course there will be 0 dogs, and in that case, the number of feet, or I should say legs, will be 12. That will be 24. Right. So if we have all chicken, that's what we have. Now, of course, we cannot have that. We need more feet or more legs. So in that case, if we reduce the number of chicken by 1, in that case, the total is still 12. So we have 1 dog. In that process, we have 11 chicken times 2 should be 22 legs plus 2 legs. 4 legs of the dog. So we say 11 times 2 plus 4. So that's 26. So every time we reduce the number of chicken and increase the number of dogs, we added 2 legs to it, right? The dogs have 4 legs, chicken have 2. So by reduce the number of chicken by 1 and increase the dog by 1, essentially we have exactly the number that we need. So therefore we have 10 chickens and 2 dogs. We said strictly reasoning, no algebra here. Right. Next I'm going to do 5, 6, and 7 kind of together. So this is the concept of equal, equivalent, or both, or neither. By the way, let me say it. Just define a few terms here. So equal, our equivalent first. To set our equivalent if they have the same number of members. In the set. Equal, meaning same members on both sets. So if it is equal, it will be equivalent. If it is equivalent, it may not be equal. So I look at this. We have 72, 40, and 27. Right? 40, 27, 72. The order are not the same, but we have 3 identical members. So in this case, it is equal. By the way, if it is equal, it is also equivalent because they have 3 members here, 3 members there, so they are equivalent. So we say it's equal and equivalent. Always say just both, because equal mean both also. So both equal and equivalent. Right, next one, 4, 12, 4, 1, 2. This one 3, this one 2. So they're not equivalent, and definitely they are not equal. So this one is neither. Because he will have 2 members, he will have 3. The number of members are not the same, so neither. He will have first, second, and third, 3 members there. 1, 2, 3, 3 members there. Same number of members. So in that case, we say they are equivalent. They're not the same, not exactly the same members, but we only say this is equivalent, meaning the same number of members. Each has 3. Right. So that's what we have. Right. Tell whether the statement is true or false. 9 is not in the set of only x, where x is even counting number. Well, 9 is an odd number. This one is the set of only even number. So 9 does not belong to it. This simple for does not belong. So this one is true. Because 9 is not an even number. Right. 9 and 10 now do together. Find the number of subsets of the set and the number of proper subset of the set. So we talk about the number of subsets and the number of proper subsets. So the number of subsets equal to 2 to the power of the number of members. Right. And the number of proper subset to the number of members. I'm just going to say 2 to numbers of members and have to minus 1. So the difference between the subset and proper subset is that subset could be equal. Proper subset cannot. So the first one I will give you. So in this case, the number of subset, there are 3 members here. So we have 2 to the third power, which is 8. Right, so I'm going to list very quickly on the empty set. 5, 6, and 7. And then 5, 6, 5, 7, and 6, 7, and then the set itself. Yeah, so if we count 1, 2, 3, 4, 5, 6, 7, 8, so there are 8 subset, so that's good. Now if we talk about proper subset, all we do is just excluding the set itself, right? 5, 6, 7. If we're excluding the set itself, now we have 7 proper subset. So the proper subset, the number of proper subset is just 1 less than the number of subset. Right, next one, for the number of proper subset, for this set has 4 members. So the number of proper subset equal to 2 to the 4 minus 1. So we have 16 minus 1. It's going to be 15. So there are 15 proper subsets. Right. The next 2 I will do together. List the element in the set. So we have universal sets that much, A, B, and C. Now we need to do A intersect with complement B, and A intersect, complement of A minus C. Right, so first, as always, we do the complement first, or the operation is complement first, and then union intersection in the same order. So we're going to do this first, and that first. So the complement of B complement of B. So we look at the set B and complement, meaning that is not in B. So we have Q already. There's no R. There's S already. So the T, U, V, W, X. So that is B complement. And then we have Y and Z already. So that is, so this is not in B. So this is not in B. Now the formula, what it has to find is A intersect with the complement of B. So A with A is that, and now would be complement. The intersection, so pretty much we just find the common of these two. So what do they have in common? Well, there's a U and there's W. So pretty much U and W. Yeah. So once again, all the operation of the sets start with complement. Of course, if there's parentheses, I'll do that first. But if all the operation there, always do the complement first, and then union, intersection, or difference. Right. So A complement minus C. So first, this is A. We have to do the complement of A first. So there's Q, then no S, the R is good, S already, the T, U is there already, there's V, W is there already, and then X, there's no Y, and then Z. Yeah. So A complement is what is not in A. So it's not going to be not W, not S, not U, not W, and not Y. So what's left is this. Now we're going to take this and subtract different from C. I'm just going to copy C here. V, W, X, Y, Z. So what we're trying to find is A complement. Subtract C, meaning it's going to be in A complement, it's going to be here, but not in C. So it's not going to be V, it's not going to be X, it's not going to be Z. Right? So what in A prime, but not in C? So the V, so it's not going to be V, it's not going to be X, it's not going to be Z, because those members are in C. We don't want to be in C. We want to be A complement. So with that, we just have R and T left. Right? I'm going to 13. I'll write a description of the shaded region using A, B, C, union, intersection, difference, or complement. So what we have here is, it is in the B and only B, right? So we say, well, if we write B, it's not going to be good enough because the B, we have to have the intersection between A and B too. So all we say is going to be B, and then we say this outside of A, right? Because anything in A does not count. Wait a minute. Actually, in A, outside of A as well. Yeah. We could not count anything inside A. We can count some of it outside A. In that case, we can just say B intersection with not A. So it's only in B, but don't be in 8. Or we can write differently, such as B minus A. So in B, but not in A. Yeah, so either way, work. Now, for the cardinal number of the Venn diagram below, we present the cardinality. So find n, the cardinal number, how many members in the set A intersect with B complement. So first of all, what it is. So A intersect with B complement, meaning it's going to be in A for sure, but not in B. So in that case, we talk about this here. Right? So it's in A, but not in B. So the answer for this is just 24. Right, next, say the region represent the set, not A, not B. Well, so usually, if we are a little bit confused of this, we just put letters, either letter, Roman numeral, or numbers. I don't want to put numbers because number usually reserved for the number of members. So let's just use Roman numeral or just letter. Have a set A and B already, so have to use something different than the capital letter. Just use a lowercase then. Right. So here I use this will be A. This is B, C, and D. So there are 4 regions. That. So obviously, if there are all 4 different regions, that is the universal set. That has A, B, C, D. In the book or in class, we use the Roman numeral, but of course, you can just use anything. Right, first, we do the complement first. So not A. A has B and C, so not A meaning A and D. Now B, not B. B has C and D, so not B is A and D. Sorry, A and B. So that's not B. And now we just do the union. Intersection. Intersection of A and B, so the common of these two, so just going to be A. Right? So it's not that bad. I'll just, if it's confusing, put all the numbers, Roman numeral, letters, whatever it is, and then do the math for each one. In this case, we have the A. The answer is A. So meaning, I'm going to set everything outside of both sets. Right, so get that. Next, Monticello residents were surveyed concerned their preference for candidate Moore or Allen. Of the 800 respondents, 300 support neither, 1 support both, and 250 support only Moore. How many residents support Moore or Allen? Right. So for this, we're going to put Venn diagram. So there are 2 candidates, Moore and Allen. Let's just put all of this number into it. So first, 800 total, we're not going to use that, not too much. 100 support both, so we know 100 in the middle, that both. And then 25 support only Moore, so that only Moore, the key part is there, so it's going to be 250 only Moore. 300 support neither, so that means way outside. And with that we can find what is the number only support Allen. So we subtract that from 800. So in that case, that 400, 650, so that's 150. And the question, how many resonance support Moore or Allen? So support Moore Allen. That also, the key here is when we say or, we mean either or, maybe both. Yeah, the or meaning including the both case as well, right? So in that case, support, we just say number of Moore or Allen. We're going to add 250 only Moore, 150 only Allen, and 100 that is both. So that is 500. Right. Now to question 17. A survey of 280 families showed that 107 had a dog, 32 had a cat, 37 dog and cat, 105 neither cat or dog nor parakeet, 9 we have a cat, a dog and parakeet. How many had parakeet only? Wow. So when we look at this, we see the universal set, and then in there we have 3 different sets, set for dogs, cats and parakeet. So the Venn diagram with 3 circles. So this we have dog, cat, parakeet. Now just put this number into the set accordingly. We just need to answer what we want ultimately is had parakeet only, so we ask about this part here. Right, so let's start. We have 9. We have to go with the most, the innermost part. So 9 of them had a cat, a dog, and a parakeet. So that's 9. And then we say 105 had neither a cat, a dog, or a parakeet. So we know 105 is going to be outside. Next, 37 had a dog and a cat. So we know a dog and a cat is this. The total 37. So we have to subtract the 9 to get to this portion here. So 37 had the dog and the cat, and we minus 9. So that's 28. Right. Now, next, we did take care of that. 82 had a cat. Now, think about this. 82 had a cat, so the total is 82. So if we take out this part here, that portion is what we have 82 subtract 28 and 9. So 82 had cat minus 28 minus 9. Right. I haven't used a calculator here, so I might as well just use it. 82 minus 9 minus 28. 45. So I have 45 here, that's only cat. only cat and maybe parakeet too. Same thing, we have 107 that are dogs. So that is the dog, subtract the 37 in the middle. So 107 minus 37, no, that is 70. So 70 is the set of here, including part of that also like parakeet. Now with that, we just take the 280 of the total, subtract all the numbers we have here. We're left with the numbers in this set. So 280 minus 70 minus 28 minus 9 minus 45 and minus 105. So do all of that. That's what we get. So 280 minus 70 minus 28 minus 9 minus 45 minus 105, and we have 23. So 23 is this region here. Right. I'll go to 18 and 19. Right. This is, we write the negation of the statement. However, this we have the quantifiers. The no here is universal. And here we have some, which is existential. Right. No fifth grader plays soccer. So in that case, we have to, if we're going to negate anything with the quantifiers, one thing we have to negate the meaning of it. For example, if it is some, we have to, some are musician. Do the 19 first here. So we said athletes are not. So first we're going to negate the meaning of the sentence. But then we have to negate, not negate, change the existential to universal. If it is universal, change to existential. This one, some, is existential. We go to universal, meaning all. Right, so that is a negation. Some are musician, and we say all of them are not. So that is the negation of it. On 18, we say no fifth grader plays soccer. Right, so the key here is the no. The no. It is the universal, but it has the meaning negative to it. No meaning not, so it's negative already. So if we want to negate it, we're not going to do anything. We said fifth grader plays soccer. And we have to change the quantifiers to existential, which we say some fifth grader play soccer. Remember, original, it has no meaning negative already, so we will not need to add the not here. This one doesn't have the, it's some, so it doesn't have negative in it, so we just throw the not to make it negation, the meaning of the statement. Then we change the quantifiers. So always change the quantifiers and then negate the statement. convert the symbolic statement into words. So P represent her name is Lisa, and Q represent the statement she lives in Chicago. Now, this is the upside down. It's going to be the conjunction, but most important, it means and. So it's going to be and. So we say her name is Lisa, and she lives in Chicago. Right, so just like that. Right, next, P represent statement Jim plays football, and Q represent the statement Michael plays basketball. Convert the compound into simples. So it's kind of the backward. So we have all of the keyword here is not and. Right, Michael plays basketball, so that's simply Q. The N upside down, and not meaning the negation P. So that's what we have. Right. Next, what we do is we'll construct a truth table for this statement. So when we see here, we only see two different statements, P and R and P and Q here. So we're just going to list all the different scenarios. So there are two statements. So we're going to have four lines. So we start with R and then P. Right. Now when we do this, the last statement on the right is going to alternate in true false. The one on its left will alternate every two, true, false. Right. So that's good. Now, just like we did said about the order operation, the negation goes first. So negation of R. Negation of R. So that R negation, true becomes false, false becomes true. Right. Now we have not P so not P so just alternating, true become false, false become true, false, true. And finally, we have not R and not P. So just the last two columns here. So this is going to be N. And for N, the key for N is that it's true when both of them are true, everything else are false. So we focus on the case when both of them are true. This is going to be true. Everything else is going to be false. So N is true every time when both of them are true, and R is false when both of them are false. Right, so that's what we have. Next we have P and Q, only P and Q. right? P and Q, right? The last one, true, false, and alternate everything to true, false, false. Now first, do the negation. Not Q. So that is Q. Negation of Q, just true becomes false, and false becomes true. Right, and then we do the implication or the if then or the conditional statement. P implies not Q. So in a conditional statement, it will be only false if we have something true imply false. So we focus on the first one. If we have a true imply false, it's going to be false. Everything else true. So first one is false. Everything else is true. Right, so keep this in mind. We just need to remember that everything else in conditional is false. I'm sorry, everything else in conditional is true. For the conjunction, this is true. Everything else is false. Just need to know one, and we can remember the last. I mean the rest of them. And then false, all false is false. Everything else is true. So we only need to remember one case, and then the rest just the opposite to that. So implication or conditional statement is false only we have true to false. Everything else is true. Conjunction, both of them are true, then it is true. Everything else is false. Disjunction, false or false is false. Everything else is true. So just need to remember the special case. Everything else just the opposite to that. Right. Right. Now, for here, use the De Morgan's law to write the negation of the statement. Right. So what is the De Morgan's law? So De Morgan's law for the negation of P. So negation of a conjunction is the disjunction. So meaning that n turn to or and or turn into n. Yeah. So we negate both statements, but the connective change. Right. Here we said a day late and a dollar short. So we're gonna negate both of them. It's not a dollar late. A day is not late. A dollar. So a day late. So we said. So it's not a day late. And we have to turn into or because that's the Morgan's law. So n now turn into or. It is not a dollar short. Right? So negate both of them and change the connective. That's 24. Right. I'll go to the next two. write the converse, inverse, contrapositive for statement as request. This we only worry about the contrapositive. So we have, if I pass, I will party. So the statement is if P, then Q. Contrapositive. Contrapositive is we're going to flip the statement and negate them both. The converse, it just flip, and the inverse just negate. Right. So this case are contrapositive, so we have to flip the statement and then we have to negate. So we said if instead of I pass, I say I will party. If I party, I do not party. Then I will not pass. Right? So I party is the second one, we move to first, negate that, and then I pass is the first, move to second, and negate that. So we have both not, and then we flip the statement. Right, 26. Q, not P, the inverse, all we do is just negate. So negate of Q implied negation of P. Now negation is the statement itself. So that's what we have. Right. Next, find the greatest common factor or greatest common divisor of the numbers in the group, and then find the least common multiple of this. So for most of this, we have to do the prime factoring and then determine. Okay, we go from there. 42. If we break down 42 using the prime number, we start with 2 and then 3 and 7. Right? Now 56, 2 and 28, 2 and 14, 2 and 7. Right? 98, 2 and 49, well, 7 and 7. Right. Now with that, we have the prime factoring of 42, a 2, a 3, and a 7. 56, a 2, actually 3, 2, and 7. And 98, a 2, and 7 square. So the greatest common factor or greatest common divisor, we're going to take the one with the least power, but have to be common. So all of them have a 2, right? So there will be a 2, but have to raise to the least power of 1, right? And then we have the factor of 7 off on 3 of them, and to the factor of common, the least is 1. So we take all the common factors raised to the least power for the greatest common factor. So we say greatest common factor or greatest common divisor. So that 2 times 7 is 14. Right, now we have these two, 20 and 29. 84, 126, find the least common multiple. So we do the prime factoring for 84. All of this we have to do the prime factoring. 2 and 42, 2 and 21, 3 and 7, 126, 2 and 63. Not 2 doesn't work anymore. Now go to 3 and 7. Right, now let's try it out. 84 is the 2 square, 3, and then 7. 126, 2, 3 square, and then 7. Right, now this is the least common multiple and greatest common factor. Right, least common multiple, we're going to write out all the possible factors, 2, 3, and 7, to the most power, to the highest. So that's what we have. So we have 2 squared, 4 times 9 times 7. So that is 252. Right? So let's recap. Greatest common factor will be the common factor to the least power. So here, for great common factor, we take the common, that bad way. Great common factor, we just take the factor that's common to everything, so that's 2 and 7, and then we raise to the least power of them. Right, and then least common multiple, we take every factor to this one, the least, so this is to the most or the highest powers. Right, so that's the summary of those two. Now, next we have these three numbers. So just do the prime factoring. 48, 2 and 24, 2 and 12, 2 and 6, 2 and 3. 162, 2 and 81. Well, 81 doesn't go to 2 anymore, but will be a bunch of 3s. And then 27. Right, now let's write out all the prime factoring of this number. 1, 2, 3, 4. 162, 2, 2 and 4, and 27, 3 cubed. Right. Now this is the least common multiple. We're going to give every factor. We have a factor of 2 and a factor of 3. Now to the highest power. Highest power for 2 is 4. Highest power here is 4. So we have 2 to the 4 times 3 to the 4. So on the calculator, this is for the power. So 2 to the 4th times 3 to the 4th. And that's 1296. Right. So that's what we have in that one. Now, if the number is given is mixed number, convert to fraction. If the number is fraction, convert to mixed number. Well, this is the mixed number. So to convert to fraction, we just multiply, add to the top. That is 37 over 4. Now, if it is the other way around, let's say you have 37 over 4. How do we convert this back into mixed number? Well, in that case, we just divide. 4 would go into 37 9 times. That's 36. So it's 1. So we have 9 whole part, 1 left, still over 4. So that is how to convert between mixed number and fraction. perform the operation and give the answer as fraction in the lowest term. Right, so it is just dividing. So when we divide, it's going to be negative and positive, so it's going to be negative. Divide meaning multiply reciprocal, divide by 3/4, multiply by 4/3. Right, now when we multiply straight across, so we have 7 times 4 over 8 times 3. Now usually we can just multiply straight across, but if we want to simplify, it's better to simplify beforehand. So 4 and 8, that will be 2. Or divide by 4 on both sides, top and bottom, so that goes out. 8 divided by 4 is 2, so 2 is left. We just have 7 over 6. Of course it's negative, right? So negative 7 over 6. Right, express this as a fraction with the lowest term. So we can start with 0.6. I'm just going to say 0.666. Now if I multiply this by 10, it becomes 6,666. If we just subtract the original number of 0.6, and now we subtract. Notice this is subtract like 10 of something, subtract 1 of something. 10 minus 1 is 9, so we have 9 times 0.6. Repeating is subtracting this on the decimal of 6 cancel out, we're left with 6. So bottom line is we have 9 times 0.6 is equal to 6. So to get that by itself, it's just going to be 6 over 9. And that reduced to divide 3 top and bottom 2/3. Okay, so we just say 2 divided by 3. Of course we have the repeating. Now, of course you can also type repeating and then convert. Sorry, don't get that. Just hit math, convert to fraction. Yeah, so that's how we do that. Right, next 33 and 34 I'm going to do together. Right, list all the numbers in the given set of real numbers. So we have natural numbers, counting numbers, and whole numbers, counting numbers, 0, and integers, meaning they have all negative. So for integers, we have, this is the natural numbers, whole numbers, and integers. We don't have a negative, and do we have we also have 0. And so we have 16 is 4, so we have that as well. So all of these numbers are integers. Yeah, so it's going to be B. Right. Next, rational numbers. Well, rational numbers, anything can be put in fraction. So that includes all the integer as well. So that is natural numbers, whole number, integers, rational numbers. Negative, integers, therefore rational number as well. 0, whole number, integers, and rational numbers. Fraction, definitely rational numbers. 12, 9 is 3 rational numbers. Repeating, also rational number. Terminating, rational numbers. So anything that is repeating, anything that is terminating, meaning it does not go on forever, I consider rational numbers too. So pretty much everything except for the square root of 8. So it will be this one. Right. Right. Next, write the number. For these two problems, we try to turn this into a number without the power 10. So meaning that we're going to turn this into the 10 to the 0 power because anything to 0 power is 1. Therefore, we're just going to ignore that. So, the thing about scientific notation is the number in front of the power of 10 has to be between 0 and 10. Meaning it have to be 1.000 something to 9.9999 something. But if we have the power of 10, if we make the power smaller, the number has to be bigger. If we make the number smaller, the power going to be bigger. So now the power goes from 4 to 0, meaning that we have to make this number a lot bigger. So make it bigger by 4. So I have to move 4 places to the right. 1, 2, 3, and 4. So in that case, we make the number bigger where the power goes smaller. So that power of 10 to 0 power is 1. So we just have 73,600. Right, next. We have the power of 10 to the negative 4. Now we go to the 4 power. Now this time we make the, sorry, need to go to 0. Because that 10 0 power is 1. So we make this from negative 4 to 0. We make it bigger, right? Negative 4. Make bigger by 4. So in this case, this number, we have to make it smaller. So the power getting bigger, the number getting smaller by 4. So 1, 2, 3, and 4. So the decimal will be right here. Will be 0, 0, 0, 0. 0.000281. Yeah. So just like that. Of course, if we make the number bigger, whether we move decimal, don't try to remember if it's left or right. Just if you move the decimal this way, number gets smaller. Move the other way, getting bigger. Just use your intuition. Right. The other direction is the same thing. So write this as a scientific notation. So originally, I can say this is 49,000 times 10 to the 0 power. Because 10 0 power is 1. I can just ignore that. Now, in scientific notation, we have to make this number smaller. So that it is between 0 and 10. So that case 1, 2, 3, 4. So that's 4.9. And that'll be 1, 2, 3, 4 places. So we did make the number smaller. Therefore, the power have to be bigger to compensate. So smaller by 4, bigger by 4. Right? Same thing on the next one. 0.000652 times 10 to the 0 power. Now we make the number that is this number too small. We need to make it bigger so that it will be between 0 and 10. So in that case, you have to move the decimal 1, 2, 3, and 4. Now you make the number bigger, the power have to be smaller to compensate. So smaller by 4. So that's what we have. Right. Next we have these two problems. Just perform operation with scientific notation. So for this, we group the numbers together, 9 times 7. And then we have the power of 10 together. 9 times 7 is 63. And then when we multiply, we add the power. So negative 1 plus negative 4. So I have 63 times 10 to the power of negative 5. Now, this is not proper scientific notation because the number is supposed to be between 0 and 10. This is bigger. So we have to make it smaller. Like that. So that means decimal have to go to this side, right? So just one place. So we make the number smaller by one place. The pound have to be bigger than by 1. So that gives us 6.3 times 10 to negative 4. Right. Next we have this one. Same thing, we just work with the number first. And then work with the power of 10. Right. Now we divide the number. .2, which is perfect for scientific notation. It's between 0 and 10. And now for this two, dividing, we subtract the exponent. Negative, negative. That becomes 2 plus 9. So 2.2 times 10 to the 11. Right. So with that, we conclude the review for the midterm in Math 1332. Thank you for watching.